I'm back here in our GeoGebra applet we used for graphing the derivative of a function, and I'm going to use it to take a guess at what the derivative of the sine function might be. So remember what this is doing, it's taking the slope of the tangent line and plotting it as a y-coordinate so we can see what the derivative looks like. So here we've got the graph of sine, looks like we remember it from pre-calculus, and I'm going to slowly drag my point along the curve. And remember this graph goes red when the slope is negative and green when the slope is positive. All right, but it's just going to trace out the function for me. All right. And maybe you might recognize this shape. It looks just like the sine function, but kind of shifted over a little bit. Notice that this graph starts off at a y-coordinate of 1 on the y-axis. That was kind of a hallmark of our cosine function. And it turns out that the derivative of sine is the cosine function if we show the derivative. All right, so starting over with cosine, we're going to see maybe the derivative of cosine is equal to sine. Let's just see if that works out. So I'm going to drag my point along and have the applet draw my derivative for me. All right, and what we get looks almost like the sine function, not quite. Remember that sine starts off at the origin and it heads up. This derivative is starting off at the origin and heading down. This is actually the vertical reflection of the sine function. It's actually equal to the negative sine of x. All right, so here's what we found from our GeoGebra applet by guessing. It turns out to exactly be the case that the derivative of sine is equal to cosine and the derivative of cosine is equal to negative sine. All right, so now we can add those two rules to our pile of derivative rules, and we can use them anytime we need to, anytime we run across a trig function, even in the middle of another function with lots of coefficients and x's. So we would take the derivative of this function. Derivative of x cubed is still 3x squared. This -5 coefficient on the sine, it's a constant multiple, and it just goes along for the ride, just like it does with x's. And we saw that the derivative of sine is cosine, so -5 cosine x, and that's all there is to it. Same question we worked in the last video, find the equation of a tangent line to f of x. This time f of x has a trig function in it, so we'll use our new trig derivative rules. And we're just finding the equation of a tangent line. So we'll write down our point slope form of a line. And the process is still the same. We're going to plug in the x value that they give us for x1, which in this case is 0. Our y coordinate is just going to be f of that x coordinate, f of 0. And our slope, as always, for tangent lines comes from the derivative. All right, so let's start off with finding our y coordinate, our f of 0. So I'm going to go up to the function and plug in, let's see, x minus 2 cosine x. So 0 minus 2 cosine 0. All right, so thinking about our unit circle, if you want to pull it out and take a look at it, cosine of 0, 0 is over on the right-hand side of the unit circle on the x-axis, and our x-coordinate there, our cosine of 0, is equal to 1. All right, so our function value is 0 minus 2 times 1, or negative 2. All right, next we need our derivative. So we'll go back up here and figure out our f prime of x. Derivative of x is still equal to 1. Then we've got minus 2. 2 goes along for the ride. It's a constant multiple. And we saw that the derivative of cosine is equal to negative sine. So we've got negative sine x here. And just to simplify that a little bit, we get 1. Let's see, that's going to be plus 2 sine x. All right, so if we want to find f prime of 0, now we're going to be plugging into that derivative. So f prime of 0, so we're taking down here. I've got 1 plus 2 sine 0. Back over onto your unit circle, 0 over there on the right-hand side of the x-axis. Sine is the y-coordinate, which is going to be 0. So we've got sine of 0 equals 0. So this is 1 plus 2 times 0, or just 1. Okay. Plug it all in, and we'll find our equation of our tangent line. So we've got y minus f of 0, which we saw was a negative 2. So y minus negative 2. Our slope was equal to 1. And we had x minus 0. It's a really simple line. So let's see, we've got y plus 2 equals 1 times x minus 0. That's just going to be x. And then we can subtract 2 from both sides. Y should be equal to x minus 2. As always, let's head over to Desmos and see if this looks right. All right, here I have a graph of x minus 2 cosine x. We found the y-coordinate on that function at x equals 0 to be negative 2, which looks perfect there on the y-axis. And we'll plug in our function, which we found to be x minus 2. And that looks like a perfect tangent line at that spot. Same function, an old question. Find the x values at which f of x has a horizontal tangent line on the interval 0 to 2 pi. So we didn't have an interval last time we did this. Let me hop over to Desmos and show you why we actually need the interval on this one. Right, so we had our function x minus 2 cosine x and our tangent line graph. Let me turn off the line. If I zoom out on this graph, you can see that this function looks like it's going to have an infinite number of places where that tangent line is going to go completely horizontal. So what they're telling us in this problem is that they only want us to find the places that are between 0 and 2 pi, which are going to be between the 0 and 6.28. And so it looks like we might have 2 places that we'll find on this graph. I told you in the last video that anytime you want to find the places where f of x has a horizontal tangent line, you just set the derivative equal to 0. So let's take our derivative. We found this on the last example, f prime of x is equal to 1 minus 2 times a negative sine x. So it made it a positive 2 sine x. And we just want to set this equal to 0. All right, so let's subtract 1 from both sides. And we get 2 sine x equals negative 1. Divide both sides by 2. And I get sine x equals negative 1/2. So we are looking for places on the unit circle between 0 and 2 pi where the angle gives us a sine of negative 1/2 or a negative 1/2 y coordinate on those terminal points. You're going to find one in the third quadrant and one in the fourth quadrant. So down in the third quadrant, you're going to find the angle 7 pi over 6. And then in the fourth quadrant, you'll find 11 pi over 6. And both of those points have terminal points with a negative 1/2 y coordinate. So those are going to be our two solutions to this equation, that x is equal to 7 pi over 6 and 11 pi over 6. And you really do need to give those answers in radians because they asked you for the interval 0 to 2 pi, not 0 degrees to 360 degrees. So even though these might be 210 degrees and 330 degrees, we need to give them as radian answers.